Now that we've thoroughly explored the bounding process, including how to compute bounds and how to combine bounds and how to use these bounds to prune nodes, we should talk about the branching process. The branching process is much simpler than the bounding process. Remember that when we branch, we split the feasible region. We start with an original feasible region P and split it into, say, two regions P1 and P2. Then we further split the region into smaller regions, computing bounds all the way along. In this lecture, we'd like to explore the different ways to branch, to split the feasible region. To talk about branching, we'd like to focus on a particularly more concrete problem. In this case, we're maximizing three variables, subject to two different constraints, and having all variables binary. There's really two ways that we can split the feasible region, and these are the two ways in general that we do it. The first is that we pick some variable, say x1, and fix its two possible integer components. In this case, x1 can equal 0 or x1 can equal 1. By fixing this constraint, we've split the feasible region into two halves. The feasible points where x1 is equal to 0 and the feasible points where x1 is equal to 1. This defines two different subproblems that we can then compute bounds on. The other alternative is to add a more general constraint. In this case, we're focusing on the variables x1 and x2. We can either have x1 or x2 less than or equal to 1, or x1 or x2 greater than or equal to 1. These two constraints are mutually exclusive, and so they split the feasible region into two halves. In general, this is the way that we split the feasible region. We're going to add some mutually exclusive constraints. And we can see that fixing an integer is actually just a special case of this. In this case, we have a constraint, x1 equals 0 or x1 equal to 1. We shouldn't be focused too much on splitting the region into two halves. We can split the region into as many components as we'd like. In this case, we have the same problem, but now we've modified the variables to come from the values 0, 1, or 2. Now we can consider a multi-cut. We'll focus again on the variable x1, but now we can set x1 equal to 0, x1 equal to 1, or x1 equal to 2. This defines three regions of P, and so P would have three children, one child for each one of these values of x1. In general, this is how we consider branching. We're going to take our feasible region and introduce mutually exclusive constraints. These mutually exclusive constraints are going to split the region into two or more different segments. In general, we're going to focus on fixing integers, and usually we're going to focus on splitting the region into two halves.